So, what if I told you there's a hidden mathematical pattern, a kind of secret geometry that connects the laws of physics, the future of AI, and, get this, the very nature of truth itself? Well, today, we're going to pull back the curtain on that exact idea.
It all kicks off with this wild thought. What if you could build an AI that literally cannot lie? And I don't mean because of some ethical programming or a set of rules. I mean it's mathematically impossible for it to hallucinate. It would be like a character in a video game trying to walk through a solid wall. The very physics of its reality just won't let it happen.
So, how on earth is that even possible? Well, we're going to follow a really fascinating trail of clues. We'll start with why AI lies in the first place, then we're going to jump back in time to find a key pattern in pure mathematics, and then we'll see how that exact same pattern is being used right now to build a whole new geometry for truth.
All right, first things first. To even think about building an AI that can't lie, you have to solve a much, much deeper problem. How do you take something as messy and infinite as human meaning and lock it inside an unbreakable finite structure?
This, right here, is the fundamental question. You know, our world is just full of these infinite processes. The endless spin of a circle, a physical law that has to apply everywhere at all times, or even an endless loop of dictionary definitions. The trick is, how do we package all that infinity so our finite computers can actually get a handle on it?
To find the answer, we have to go on a little trip. Back to 1735, to a mathematician named Leonhard Euler. Because as it turns out, the first big clue, the Rosetta Stone for this entire idea, was found while he was wrestling with a completely different problem. Okay, so this was basically the Mount Everest of 18th century math. The setup sounds simple enough. Take all the whole numbers, square them, so 1, 4, 9, 16, and so on, and then add up their inverse fractions forever. Mathematicians knew this infinite sum was closing in on a specific number, but for decades, nobody could figure out what it was.
But just think about this for a second. It's all just arithmetic, right? There are no shapes, no angles, no geometry anywhere in sight. It's just an infinite pile of fractions. And that's exactly why the solution came as such a complete and utter shock.
The answer was pi squared divided by 6. Pi, the number that defines a circle, just appeared out of nowhere. It was this stunning moment that revealed a really deep truth. The continuous, flowing geometry of a circle was secretly hiding inside this discrete, infinite list of numbers all along. And this gives us our first core concept, the finite invariant. You can think of pi as a kind of mathematical budget for rotation. It takes an infinite process, a spin that could go on forever, and perfectly compresses it into one single computable number. This is the key. This is the mechanism for taming infinity.
Okay, now let's fast forward to today and see how this exact same pattern is showing up in artificial intelligence. This time, it's the key to making an AI that can genuinely understand the laws of physics.
You see, a standard AI is basically what you'd call a blind interpolator. It's like an actor who's memorized a bunch of complex medical lines for a TV show. They can say the words perfectly, but you wouldn't want them doing surgery because they don't actually understand biology. A physics-informed neural network, or a PIN, is totally different. It's an equation-aware solver because the actual laws of physics are hard-coded right into its learning process.
And this visual makes the difference crystal clear. On the left, a standard AI just connects the dots it's been shown. But look at the right. The PIN is forced to obey the laws of physics everywhere, even in the gaps between the dots. The equation itself becomes a part of the data, filling in those gaps with mathematical certainty.
So how does it do this? Well, it's our pattern again. A law of physics is an infinite constraint, right? It applies everywhere. A PIN tames this with something called a PIN residual. It's just a finite number, a penalty score, that shoots up anytime the AI's prediction tries to break the laws of physics. The AI gets mathematically punished for hallucinating an impossible reality. So, we've seen this pattern tame physical geometry with pi, and we've seen it tame physical laws with a PIN. Now, for the main event, we're going to apply this exact same structure to the most chaotic, most messy infinity of all, human meaning itself.
And this slide is so important because it shows the connection isn't just a metaphor, it's a direct one-to-one mathematical mapping. The underlying structure is the same. In the same way a PIN gets a penalty for breaking physics, this new architecture for meaning, called the semiotic web, gets a penalty for breaking from verified reality.
So how do you build something like this? You do it systematically, layer by layer, using what's called the arity ladder.
The best way to think about it is like building with Legos. You start with the simplest little pieces, the binary bits, then you snap them together into pairs to form basic relationships. From there, you build three-part structures to create grounded meaning, and finally, you assemble the whole thing into a four-part engine that can actually process it all. And here's the really clever part. At every single step up this ladder, the system uses a cryptographic hash to basically freeze the level below it. This creates a rock-solid foundation. It means you can keep adding more and more complexity in an orderly way, without ever risking the whole thing collapsing into a tangled mess. Each new layer can completely trust the one beneath it. Now, the most important step on that ladder is the triad. This idea comes from a philosopher, Charles Sanders Peirce, and he said that real meaning always has three parts. Let's take the word apple. You've got the symbol itself, the letters APPLE. Then you've got the actual physical apple you can hold in your hand. And finally, you have the idea of an apple in your mind. If you take away any one of those three, the word, the object, or the idea, the meaning just falls apart. You need all three. And this brings us right back to our original pattern. In language, we have this problem of infinite regress. Think about a dictionary. It defines a word using other words, which are defined by more words, and you can get stuck in an endless loop. This system tames that infinity. It uses a SHA-256 hash as a kind of funnel, compressing that potentially infinite chain of interpretation into one single, stable, 32-byte address. Okay, so we've built the architecture. Now for the payoff. This whole structure creates a fundamentally new geometry for truth, and that is what ultimately solves the core problem of AI hallucinations. Here is the key geometric difference. You can think of today's AI models as organizing their knowledge on a curved surface. Imagine a knowledge map stretched over a bumpy, uneven sphere. But the semiotic web, because all its relationships are locked in by cryptography, operates on a perfectly flat surface, like a predictable, even grid.
And this is why that difference is so incredibly important. There's a famous theorem in math that proves you cannot flatten a curved surface without tearing it. Just think about trying to flatten an orange peel. It's impossible, right? It's always going to rip or tear. When we try to force safety onto today's AIs, we're basically trying to flatten that peel. We aren't fixing the errors, we're just creating new tears and bulges, hallucinations, somewhere else. A flat space has no curves, so there's simply nothing to tear.
And this brings the whole thing together one last time. In the physical world, an infinite rotation is tamed by the number pi. In the world of physics, an infinite law is tamed by the pin residual. And in the world of meaning, the infinite chain of interpretation is tamed by a 32-byte cryptographic hash. It is the same geometry, repeating 3 times.
So I'll leave you with this question to chew on. If there's a geometry for physical reality, and now a geometry for computable meaning, could there be a geometry for our own intuition? You know that aha moment when all the pieces just click into place? Is that feeling itself a kind of computation? One whose shape we are only just now beginning to discover.